And in this video I'm going to be talking about vectors in 3 dimensions and a new way of specifying a vector. So it's going to be a little confusing. It's going to start out pretty easy though. We're going to have a displacement vector, and it's vector A, which is 40 meters, 30 degrees above the x-axis. That's one way to identify vector A, with its magnitude and angle. And if I know the magnitude and angle, it's really easy to sketch the vector. Okay, it would look something like this. Okay, here's my origin. Here's my y-axis. Here's my x-axis. And it says it's 30 degrees above the x-axis with a magnitude of 40. So I'm going to label this as 40, 30 degrees, and this is vector A. Okay, so that was pretty straightforward, and that's one way to identify the vector. Now, when I look at this, this also has unique x and y components. This is ax, this is ay, and we know we can use sine and cosine to find them. So ax is the adjacent side, so I'm going to use cosine. So it's going to be 40 times the cosine of 30. So ax is equal to 34.6. And ay, I would use sine. And ay is 20. Now, like I said, those are also unique. So another way to identify the vector is to give its x and y components. All right? And so I can say A is 40 meters at 30 degrees above the plus x-axis. Okay? Or I can say A is, now one way I could do is maybe list the components as x and y coordinates. And from either one of those, I could draw the vector. So either one perfectly describes that particular vector. Now, there is a shorthand way of showing the components called unit vectors. Okay? Unit vectors are I. You put a little hat over it to show that it's a vector. Okay? And that is a unit vector, meaning it has a length of 1 in the plus x direction. And J is a unit vector in the plus y direction. Okay? So another way to say vector A here, okay, a little arrow over its designated vector, is equal to 34.6 in the x direction, or 34.6 times that little unit vector I in the x direction, plus 20j. So our general form, let's say we have a vector called v, could be vx in the I direction, plus vy in the j direction. Top of the next page. All right, so now we're going to go backwards. We're going to be given the unit vector notation, and we want to find out what v is. So it's 3, this is the x direction, and minus 5, j is the y direction. So if I was to redraw that vector, I could start at an origin. Plus 3 in the x direction means go 3 this way. Minus 5 means go this way. And then this is vector v. How am I going to find it? Just use Pythagorean theorem. So v squared is negative 5 squared plus 3 squared. So then v is going to equal the square root of negative 5 squared plus 3 squared. If I do it, I will get v is equal to 5.83 units. And maybe I'll label that on here. 5.83 units. Now, if I want to find the angle I'm going to find that angle right there. I'm going to use tangent. So tan theta is the opposite. I don't really have to worry about the negative sign. It's just 5 long. Over the adjacent is 3. I'll get theta equals 59 degrees. So now I can go back and say vector B is equal to 5.83 units at 59 degrees below plus x. So that's one way of expressing B, and the other way is with this unit vector notation back here. Now, in general form, when I want to find the magnitude of a vector, I'm going to find, say, the magnitude of A is going to equal the square root of ax squared plus ay squared. Okay? It's kind of like the distance formula in math. So we're going to use that a lot. Now, a bit of complication of this is in physics C, we're going to be able to deal with 3 dimensions. So north, south, east, and west, and then up and down. So here's an example. I have the x direction going out this way. Okay, I have the y direction going this way, and then z is up and down. Okay, so the unit vector and the z direction is k. So we're just going to add one more term. If I want to express vector A, I can express it as ax times I plus ay times j plus az times k. Still going to use the Pythagorean theorem to find the magnitude, so we just have to add in the third term. So the magnitude of A is going to equal the square root of ax squared plus ay squared plus az squared. Now for the angle, it actually gets very complicated. You actually have 2 angles. Okay, one between in the x and y plane, and the other one in the z plane. So we don't really bother with the angles. Top of the next page. Adding and subtracting vectors. And the nice thing is, adding and subtracting becomes very easy with the unit vectors. Okay? Here's vector A is 6i minus 5j plus 4k. Vector B is 3i minus 5k. Finding A plus B. So if I want to find A plus B, I would do 6i minus 5j plus 4k plus 3i plus 0j minus 5k. You don't have to show that 0j, I'm just doing it to show you how it works. Right? Now I can just add the I terms. So that's going to be 9i minus 5j, and then 4k and minus 5k is going to be minus 1k. So that is vector A plus B. So that's actually very simple. If I want to do A minus B, I just do 6i minus 5j plus 4k minus 3i plus 0j minus 5k. I just have to remember to distribute the negative. So 6i minus 3i is 3i. Minus 5j minus 0j is minus 5j. And then 4k minus a negative 5k is plus 9k. So part of the reason that we use this IJK notation is it makes it very easy to add and subtract vectors, and also to multiply vectors, which we are going to learn in the next couple lessons.